Yeah, but then kind of getting at this point of, is the data online, labeled or not? It's not. And in some sense, the vast majority of data we have in the world is not labeled. And so there's actually another branch of machine learning called unsupervised learning, which really deals with, in a case where you don't have answers about your data set, is there still some way that you can learn some underlying structure in your data set and use your knowledge of that structure to do something? So one example is clustering. So if you have a bunch of images and you don't know what they are, you could still try to figure out some machine learning algorithm that sorts images into buckets based on which images are the most similar to each other. And then maybe a human can go later on and say, oh, that's the cat cluster and that's the dog cluster or something like that. But the algorithm doesn't know that. It's not able to assign semantic meaning or anything like that to that cluster. It just knows that those things are similar. And even though it's not shown on this kind of base image, which I don't have an attribution for it because it actually pops up everywhere on the internet without attribution. So apologies to whoever the original creator is. But generative AI is a type of unsupervised learning, where basically you're asking your model to take in a data set, in the case of GPT, the internet, and learn something about the structure. So what does a coherent sentence look like? And then when prompted, spit out something that fits what the model thinks a coherent sentence looks like. And I'm using the word coherent, specifically to mean it's not a truthful sentence. It's not necessarily a quality sentence. It's a sentence that matches the linguistic patterns that we see on the internet. So GPT is basically doing next word prediction. So it's saying, I have this data set of the internet. If I see a certain set of words, I know from my data what word is usually next. So let me just figure out when I see a particular sentence, what word is next, and just try to generate something like that for you. But again, there's nothing inherently encoded in there about kind of truth or knowledge. It is really parroting what it thinks it sees in the underlying data set.
You've mentioned a couple times images, so I assume video and still images, but also words. And I assume that between supervised and unsupervised learning, they're both equally similar in terms of an image or a video or words. Is that right?
Yeah, so the general kind of paradigm, you can kind of, it applies to kind of any kind of input data, be that exactly like images or words or physics data or anything like that.
Numbers or something.
Mathematical statements and equations.
Yes. Yeah. So in principle, you can any of those things. In practice, some of those problems are harder than others. Getting a machine learning model to output the correct answers to mathematical questions is harder to do from raw data than other things. And in part because we're less forgiving if an output is wrong. If an image is a little bit blurry in the machine learning output, we tend to be like, okay, but it still looks pretty real. If a math problem is a little bit wrong, it's wrong. And so there's an extent to which our evaluation of these things also affects how we feel about the inaccuracies in the output.
Yeah, you've underwritten the home in Florida just a slight bit off. Your insurance policy is underwater, literally.
Exactly. So yeah, this general question of thinking about what is a sort of critical setting where we really need to trust the output versus one where we're okay with it being a little bit wrong. These are very different sets of settings, and the way we should think about using machine learning in those settings is truly different.
Yeah.